All right. Hello, algebra students. Welcome to part two, day two of 11.1, Simplifying Rational Expressions. We just want to go over a couple reminders from yesterday. All right. What does it mean to simplify rational expressions? Okay. And so remember, the numerator and denominator must have no common factors other than one. So yesterday we looked at just a quick warm up here. Um, if we have this expression here, x minus 8 times x plus 7 over x plus 7, these x plus 7s are like groupings, and so we can cancel those out because remember, that's really another way of saying 1, right? And so what we have left over is x minus 8, right? And so our simplified version here is x minus 8. And remember, for excluded values, we look at the denominator and we determine what x cannot be because remember, one of the most basic rules of math is you can't divide by 0. And so in this case, what would make the denominator 0? Um, right? In this case, it would be negative 7. And so that's what x cannot be. So x cannot be negative 7 here. All right? Over here for the second one, I'm seeing that the quantities 2x minus 3's can cancel out. But I'm also going to be careful because the outer factors, 5x and 10, this 5 and this 10 simplifies to 1/2, right? And so, you know, it missed all of the green marks. You have to see what's left over, right? You have an x up here that's left over, and then we have the 2, and we have an x plus 5 still. Right, so that's what we've got. So that's your simplified rational expression. We have x over 2x plus 5. Okay. And for the excluded values, we look at the original rational expression, right? We look at, we don't need to look at the 10 because it's just 10. It's not 10x or 10x squared or whatnot. It doesn't have a variable, and so we're going to look at these two factors of x plus 5 and 2x minus 3, and if we set them equal to 0 and solve, we would get x equals negative 5, and here this is going to be x equals 3/2, right? And so those are excluded values. Those are what x cannot equal, negative 5 and 3/2, right? And so we're going to do a bit of an extension today. Okay, it says today we're going to include factoring first. So this is stuff from the beginning of second semester. I know it seems like that was quite a while ago. All right, but we're going to use two types of factoring. We're going to use greatest common factor. Remember, that's GCF. And we're going to factor a trinomial with a leading coefficient of 1. So we're going to, I know on your note sheet you have like a T table here, but I'm going to go through the greatest common factor first, okay? And when we go through the greatest common factor, we're looking at between the terms, what factors do they have most in common, right? And so here between, and I'm going to take it step by step, just looking at 6 and 12, what number divides into 6 and 12? Now, we can say 2, right? And that's true. 2 goes into 6 and 2 goes into 12. But we want to try to come up with the greatest common factor if we can. And so between 6 and 12, I'm seeing that the greatest common factor is 6, right? Now, we also need to do the variable x, right? Both of these terms have an x, and the question is, how many x's do they have in common at most, right? And so they have one x in common at most, right? I know this is x squared, but this one, the second term is just an x, and so they only have one x in common. Now, there's a couple ways to go about this depending on how your teacher taught you, but one way that I like to think about it is, all right, our greatest common factor, our GCF, is 6x, right? I'm going to erase this so there's no confusion. And so 6x, if we were to distribute it back in, 6x times what here is 6x squared. We know that's got to be an x, right? Because 6x times x is 6x squared. And then 6x times what over here gives 12x. That's got to be 2, right? So this is the factored version of this binomial, all right? Now for this one, 2x minus 8, again, looking at the coefficient, 2 and negative 8, right? What number divides into both 2 and 8? Greatest. That's going to be 2. Okay. Notice the first term only has an x, and so because the second term does not have an x, then there's no x to take out. And so our greatest common factor here is just 2. Okay. And so I know this is going to be a minus sign. And again, if I were to distribute it back in, 2 times what is 2x? That's going to be x. 2 times what here is 8. That's going to be 4. Okay. Take a moment here. You can pause it. And what would this factored version be here? Right? If you came up with 2 times the quantity 2x plus 1, that's great. All right. And I think the more difficult part, right, even though it's been a while, but I think we'll be okay, we looked at how to factor trinomials. Now, this is on the right side of your table, okay? I think all of your teachers did something very similar to what I'm about to show you. When we have a trinomial, right, we're going to focus on the middle term, the negative 3, and the constant, negative 28, all right? And so my students, we used what's called the diamond method because of this one activity we did before we started this unit. And so we take this middle term, and so this is up here and the negative 28 down here, meaning we're thinking what multiplies, we need two numbers that multiply to negative 28, but at the same time adds to negative 3, right? Two numbers that multiply to negative 28 and adds to negative 3. And so when we think about it, you can list out factors of 28, right? I know that one of them's got to be negative, and so I know that's going to be negative 7 and 4, okay? Because that multiplies to negative 28 and it adds to negative 3. Okay, so when we factor, right, we know that it's going to factor into two binomials, right? That's going to be x and x because that's how we get the x squared. And the numbers that we come up with here are going to be part of your factors. That's going to be x minus 7 and x plus 4. Okay, so again, I know it's been a while since we've done this type of factoring, but it is a skill that is going to keep coming up, right, as you can see in this lesson. So the same idea applies here, okay? Middle term up at the top, negative 8. Bottom, or the last term, 15 down here, okay? So what multiplies to 15 and adds to negative 8? Now you got to be careful with signs, right? Because if it multiplies to a positive and adds to a negative, that must mean that my numbers are both going to be negative, right? Because a negative times a negative is positive, and a negative added to a negative is still a negative. And so this is going to be negative 5 and negative 3, right? So my factors here are x minus 5 and x minus 3. Okay. All right. You can try the last one, all right, and see if you get the following. All right, you should have gotten x plus 8 and x minus 4. All right. Now we're going to use all that and apply it to the lesson from yesterday, right? So can we put that all together now, right? We're going to simplify this rational expression. We have an x minus 2 over x squared minus 7x plus 10. One reminder here is, remember, you cannot just go canceling out these x's, right? One way that I like to think about it is that these are groupings, Okay, x minus 2, the x is part of the group. So you can't just cancel out part of a group. But this trinomial, right, is what we just covered. We're going to factor this x squared minus 7x plus 10. So there's my setup. And so here are the factors, right? Well, multiplies to 10 and adds to negative 7, that's going to be negative 5 and negative 2. And so when I rewrite this, this is x minus 2 over, that's x minus 5 and x minus 2. And these x minus 2's can cancel out, right? Now, one thing you got to be careful is it is not x minus 5. The x minus 5 is in the denominator, and so we need a 1 up here. So this is 1 over x minus 5, right? So that's the simplified version. The excluded values, I'm going to take from here the x minus 5 and x minus 2, right? And what x cannot be would be 5 and positive 2. Okay. All right. Okay. For the sake of time, I'm going to skip this next one here. And let's do this one here. 2g cubed plus 8g squared. Now notice that's not a trinomial. And so what I told my class is you always want to try GCF first, right? So up here, we do have a GCF of what goes into 2 and 8. That's going to be 2. And I also noticed there are g's, right? How many g's do they have in common? 2 of those, so 2g squared, right? And so that's my GCF, 2g squared in the numerator. And so 2g squared times what is 2g cubed? That's going to be 1g. And then 2g squared times what is 8g squared? That's going to be times 4. Okay. So there's the factored version of the numerator, and down here we still have the g, right? Now there's no g plus 4 to cancel out, but I'm noticing here there's a g squared and 1g. That means one of these g's can cancel out, and this g can cancel out. And so we have a g left over here. So we have 2g times g plus 4. Now if you want, you can write it over 1, or you could just leave it like this. Okay. For the excluded value, if you look at the original denominator of g, right, what can g not equal? G cannot equal 0. Right, so when it's just the variable by itself. Okay. Now this last one is a combination of everything, right? The top is going to be a trinomial factoring. So what multiplies to negative 18 and adds to negative 3? The bottom is going to be a GCF factoring, right? What's the greatest common factor that you can take out? I think 1c you can take out, so that's going to be c plus 3. Okay. Up here, what multiplies to negative 18 and adds to negative 3? That's going to be a negative 6 and a positive 3. All right. So putting that all together, okay, up in the numerator, I'm going to have an x minus 6 times an x plus 3 over, or I'm sorry, those are c's, aren't they? Right? C's, 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 c. Let's change those to c. And then down here we have a c times c plus 3. And I'm noticing that c plus 3's cancel out, and that's all I can do, so I have c minus 6 over c. And for the excluded values, I'm looking at this denominator here before we cancel things out. This c, the GCF, is a variable, so we know that c cannot equal 0. And then from c plus 3, we know that c cannot equal negative 3. All right. So that's all I have for you here. I know there's some practice problems, but I'm going to stop the video here and have you guys try the problems, and the notes key will be uploaded for you to check.